That was exciting. So today I'm going to be talking a little bit about demystifying production-ready apps. And I have production-ready in quotes because that's a term people throw out a lot. But what does it really mean? Before anything else, I just want to say this is a beautiful city. It's my first time ever coming, and I really enjoy it. But now, when it comes to production-ready, your offering, your service, your application, it's production-ready when it slightly exceeds your customers' expectations, and you can do that reliably in a way that you can grow in the future. And I say slightly exceeds because any effort you're putting into making your service better than other people are going to use it is effort you can't put into developing new features or making better code. So it's only going to be slightly better. And now, hopefully, these expectations are explicit. Hopefully, there's a service license agreement or some service level agreement that says, hey, we have an uptime of a certain percentage, and you can always bank on that. And that's something that at Google they do really well, and they've publicized that pretty well. I always like to think in pictures and funny stories and whatnot. And so I'm from America in the States. We talk about the Three Little Pigs a lot. It's a fairy tale. And when it comes to production readiness, the Three Little Pigs is slightly different. Because when I was researching this, I found that there's really two parts of this problem. You have your application, and then you have the infrastructure your application is on. And so, like the Three Little Pigs here, if any part of that is wrong, you're not production ready. So pig number one has a great application. It's really well coded, well designed, well thought out. But the actual infrastructure, the servers and the machines that it's on, the networking setup that it's on isn't working well, then that's not a production ready app. And that's all the user sees. Pig number two has the opposite situation. Their app is crap. It's not very good. But they have the greatest infrastructure. They're using GKE or AWS or something. They can scale up and scale down however they need. But the app still can't meet people's needs. They're not production ready. And then finally, when you have best of both, you have an application that can serve users' needs. It's well coded, well designed, well thought out. And you have infrastructure that can meet that need, the scales and the demands that come from people using the app. Then you're production ready. So today I'm going to talk about one happy path to that. It's not the only way to say I'm production ready. It's just one known good. And so I'd like to use this hourglass here. On the bottom axis, we have everything you could try. And the top is efficiency and how good you're at it. So what I'm showing is continuous integration and delivery. And basically that, to me, is the linchpin to production-ready systems. Because from continuous integration, from continuous delivery, then you can hook on a lot of advanced features like automation or role-based access control, monitoring, and so much more. So CICD is the start. If you said, hey, am I production ready? The first question I ask is, can you deliver code? Can you roll back code? Can you ensure that your application is working, at least how it was coded at all times? So that's the very first question I would ask. So really quick, I want to talk about the cluster. When we had our little pigs example, we said this is a two-part problem. You have your application, and your application is like a house sitting on top of the solid ground that should be your infrastructure. So if the cluster is bad, if the infrastructure is bad, it's like building a house on really shaky ground. That doesn't make any sense. And so for infrastructure, just an example, we talked about SLOs and SLAs. And so whatever infrastructure you use, whether you're using something on-prem, AWS, Azure, GKE, they're going to publish certain standards. And so I highlighted on the slide the uptime guarantee that GKE gives you. And with infrastructures, you're going to get a lot of different features because basically if you're using someone else's infrastructure, they're managing all the machines for you. And so that's nice. And so you might get things like cluster auto-scaling. So based on your workload, assigning more machines to you or less machines to you. And so there's a lot of power there. What else? Sometimes things like high availability or SSDs for really fast access to data and resources. But again, having really powerful infrastructure isn't really helpful if your application is broken. And so I want to talk about an application right quick. So here we just have a silly demo application that can run as a front end or a back end. It kind of mimics a microservice. And how it works is when it's in front end mode, it's going to look for a back end. And the back end is going to display information to it. What infrastructure, what machine am I running on? What version is running? So again, it's a really simple app. Now, with continuous integration and deployment, you get a new kind of workflow. And so one other thing I want to talk about is, again, this is using Jenkins. But for continuous integration and deployment, there's a lot of different tools. There's Spinnaker, there's GitLab. Most of the principles are going to be the same. So one of the things is this lives inside of your infrastructure. So like you have applications running in the infrastructure. So here in this case, we have Jenkins running in the infrastructure. It's kind of cool. And I'll show a little bit more about that in a little bit. So I want to talk about the workflow this enables. This might be hard to see. I'm going to break it down in the next few slides. But basically, it's like, what kind of workflow do I want for my developers to say that, hey, the application and the developer workflow, that's production ready? So the very first thing is you have developers and they write code, right? A lot of times this is local. They're writing it on their own machine. And there's some problems that run in there where as the environment doesn't completely match the environment the actual code is going to live in when it ships. So there's inherently bugs in that process because there's inherent differences. But so the idea is that our developer writes code, he pushes it up to a repository like Git somewhere. From that code repository, there's an application that's watching it for changes there. And it's going to wait. And if it sees a change, it's going to kick off some actions that the user defines. So in this case, what we're going to do is, with Jenkins, we're actually going to create objects inside of Kubernetes. And my coworker actually gave a talk about Kubernetes earlier. I'm going to go over the very basics of it. But basically, it's a way to manage machines. All right, so once this Jenkins thing kicks off this basically new environment inside of our Kubernetes cluster, it's going to mirror what we actually see in production. So now the code is living in an environment a lot like production. So from there, the developer can take steps to push that into exact production or into a staging environment that's only a small percentage of a production environment. So that's the workflow we want to enable. And I actually have a video that I'll show, and I want to talk through it. So here's the old Jenkins UI. And what's going on is, you can see we have two branches set up, and these branches mirror our production and staging environment. So we might have, say, 20% of our cluster is staging, where we push code first, and then we're going to push out more code once it works. So when we create basically a namespace, we're creating a space to put our code in. So one of the things with CICD is that it allows us to partition off our code away from other people's code, so it's all safe. So now what I'm doing is, in the demo, we create a front end and back end, and we scale it up so that we have, like I said, that small percentage that's staging, and we have a small percentage, or we have the majority that's production. This allows us to test our code out cautiously. Because one of the things that happens is when we push out code, if we push it out all at once, we can take down all of our instances, and that's not production ready. So once we push out code and we know that we have a known good running, that's when we're actually roll it out to the rest of our fleet, the rest of our application. So when that's running, I'm just going to check and make sure that it's working and whatnot. You can see that when we kick off builds, we can see that our application will get updated. So the color's going to change on this a few times. The version's going to change. And again, this is a really simple application. This is just an example. You have a much more complicated application. But so how the workflow works, we talked about this. A developer is going to kick off a new code change. So you make a feature branch. This is all happening locally. Once that change gets pushed up, our CICD tool, in this case Jenkins, is going to watch for that. And it knows how to create environments inside of our actual cluster for us. So you just commit it with your, in this case, Git. So I'm going to push that code eventually. And once that's code up there, once that code has been pushed up to the repo that Jenkins is watching, Jenkins will kick off a new build for us where it will test our code, build our image, push our image to a container registry, and then actually create a namespace for us. I always think it's cool to watch this process of everything going green. I like that. So now, yeah, if we were to look inside of Kubernetes, we'll be able to see this new namespace kicked off and this new feature branch. So now the next step. You've pushed out your code. It's in the production-like environment. So now it's really easy to just use current tools. Like, I'm pretty sure most programmers in here have used something like Git. So now just checking out and merging in a branch of code and then pushing that back up allows you to automatically deploy your code into a new environment. So this is something that you can set up once, and it's going to give you a lot of gains over time. Because it standardizes this process, and it allows one person or one admin to kind of control who can access what, when, where, and why. And as your application scales and as your team scales, as your enterprise scales, that's really important. So yeah, once we see that this build is finished, we can actually check, and about 20% of our requests should be returning a new version of our application. And you can see there we have version 3. Well, you might not be able to see there. But some of the numbers coming up, most of them are reporting version 1, and about 1 in 5 are reporting the new version of the application. And so on our end, the developer, all they did was merge a branch, check out some code, push some code, and all of this environment got created for them. Once that looks good, then you do the same process one more time. And so in a second, a little bit later, I'll show you actually how that's set up. But once this change is pushed out, you can see that our code has been updated. We had 5 instances of our application running here. Well, then we're getting all of the new version. So we were able to create a new environment, push code to it, ensure that it worked, test it out, without actually touching any of that or talking to that. So that's a lot of power. So let me get out of here. So if we were to look at how that works, or what's going on there, most of your CICD tools are going to have some kind of file or a configuration file where you can specify behavior. They call those pipelines. And what we saw was just a pipeline, like end to end. What's the workflow we want for our developers and why? And so here we're specifying that. We build our image. And an image is just an instance of our application that can run. It has an environment package with it, so it can run hopefully on most machines. So we take our application, we package it up. We ended up pushing it into a registry so that we can access it anywhere. In this case, it's getting pushed to Docker. And then what's happening here is, if you guys noticed, I checked out a feature branch, and that created a new namespace for us. We checked out our staging, and that pushed our code to 1/5 of our total running instances. And then after that, we took our code from staging into production and pushed it all to the rest. So what happened is, Jenkins is literally watching for the branch names that are being merged here. So if it's Canary, that's our staging branch. If it's Master, that's going to be our production branch. Anything else, it's going to create a brand new developer environment or a feature environment. And so how that works is pretty simple. It's just running shell scripts calling the command line tool that a developer would normally have had to run to do this himself. So now this is standardized across everyone in your team and everyone in your enterprise. So let's talk about Kubernetes just a little bit. Kubernetes is an orchestration framework. So if you have, we talked about containers, and they're just a way to package up an application and distribute them. And when you're coding, generally we're coding applications or services. But what happens is they're really hard to manage at scale. And so Kubernetes is a way to manage these at scale, manage a lot of them across a team, across an organization. It's open source, it's open API, it can be used with like AWS or GCP, Azure. And it's based on a lot of Google's experiences. So Google ran a very similar system for the past like 10 or so years, and then they open sourced it as Kubernetes. Now, in Kubernetes, the application is called a pod. And so that application we showed, it's packaged up into a pod. And you get a lot of benefits from these, where you can share data among containers inside of a pod. They get one static IP address, or one IP address that they can you can use to communicate with the pod or with the application. And containers inside of a pod know how to play nicely. So here, if we're looking at our actual Jenkins, so Jenkins is sitting there and it has a lot of data. So Jenkins, if we note, and this is the file that actually is used to create the Jenkins service. And so we're specifying around here a volume. And basically what we're doing is we're saving off data from Jenkins so that if it goes down for some reason, it's not going to lose all of our data. And so pods allow you to do that. They allow you to mount data to running services and applications. You can also do things like request how much space needs to be available on an actual machine to run your application. And so these are the kind of production level concerns that you start worrying about as your application scales and grows. Like, should my application be allowed to run on this machine? Why or why not? So things like Kubernetes and CICD, they allow you to specify those in config files somewhere. So we use labels to specify the difference between our production and our staging environments. And labels are just arbitrary metadata. So I had one label that was canary, one that was master, and that allowed us to send traffic between the two. So yeah, labels, you use selectors basically to pick up different labels. So if I said, give me everything that's V1, version equals V1, in this case I had two application instances, two pods running, that would select both. If I had a different selector, maybe track equals stable, that would only select one. And you can use that to route traffic to different app instances to dynamically pick them up. And that's what services do. If you think of a service, if I had a front-end service, that's something I always want to be able to access, and I don't really care what's backing that service. I just care that I can access it and I get the expected data back. Well, so the abstraction in Kubernetes is also called a service, which is kind of confusing, but it's a persistent IP address for applications. They use labels to dynamically pick up and say, who do I target the traffic to? And so we saw in the background, that's what Jenkins was doing. Jenkins will kick off a new job, and it'll dynamically route traffic to it based on labels. And the other concept we're using here behind the scenes is called ingress. And that's basically a reverse proxy or SSL termination, similar to Nginx. The last thing to talk about is deployments. Because what we're doing here is a deployment is basically used to manage application instances and make sure that we have the right number running at all time. So on screen right now we have two servers, two nodes. And right now everything is fine in the world. But if we specify and say, hey, we want two versions of our app running, Kubernetes will notice and say, hey, that's not right. We don't have two, and it'll kick off. We get two, we're fine. If for whatever reason, if a user goes and shuts down an application, or if a machine goes down, or whatever, then deployment's job is to watch that and make sure that the right number of app instances are running at all times. And so here it kicked off a second one and ran it. And then finally, namespaces. You can think of a namespace as a virtual cluster. So an application is going to live on machines somewhere, and that's called a cluster. But being able to subdivide the actual physical machines that you have or virtual machines that you have into logical clusters is very important because it gives you multi-tenant environments. And so we used this earlier because we had a developer branch that was just a developer branch where they couldn't access anything in production. That means they couldn't delete any of our running instances. They couldn't mess up any of our settings. They couldn't take down our application. We also were able to separate production from staging that way. And so our virtual clusters lets us set basically cluster-wide defaults, like access control for different people using different environments. And that's a lot of power. So I showed you guys the Jenkin file earlier. And I'll probably show it just one more time. So here what we're doing, you can see around line 24, we're actually calling Kubernetes. That kubectl is a tool to call Kubernetes create objects. And we're actually creating objects inside of different namespaces depending on these branches. So here we're actually creating a new namespace based on whatever feature branch. So it's completely separate from any of our code that lives in production. So this namespace allows us to separate out environments and have a multi-tenant environment with different rules and different configs and different settings. So we talked a little bit about what does production ready mean. And again, it means that you can slightly exceed your customers' expectations sustainably in a way that lets you go forward. Because sometimes it's really easy to rush to get some features out and then have a horrible nightmare of code left over when you can't grow. So that's not production ready. And we talked about the three little pigs of production readiness, right? Some people might have a great app, but it's not on an infrastructure that can scale up or scale down. Here, this is running on GKE, AWS, it's all the same. An infrastructure that allows your program and application to grow over time. On the other hand, even if you're on something like GKE, which is really powerful, gives you a lot of tools and a lot of benefits, if your application isn't well designed, if you can't test it, if you can't push out code updates quickly and roll them back quickly, you're not production ready. So you need both of those. And they're two separate concerns, really. So we talked about just one happy path here. I see CICD as the linchpin, the first step, the jumping off point. Because from CICD, you can get a lot of things that we didn't talk about here that are equally important, like access control. So IAM or RBAC is one. You can get monitoring and automatically rolling out code updates or pulling back code updates based on monitoring. So there's a lot of power that comes once you have CI/CD. And so if you want slides, videos, and resources, go check out the link. You can go see a lot of the code, explore it. There's actually a step-by-step thing you can walk through. And that's just at kubetalk.com, welcome.infoshare. But these were some of the questions you should be asking yourself if you're curious about production readiness. Is my application production ready? Can I deliver code continuously, test it out, make sure that it works, roll it back if I need to? And then my actual infrastructure itself, separately from the app, can that scale up to meet my needs in a way that I can afford, in a way that's going to continue to service application needs as we grow? Thank you guys so much.